Cox proportional hazard regression in STATA. Cox proportional hazard or hazard regression analysis is one of survival time analysis method. It analyzes the duration of time until an event occurs. An event can be death, occurrence of a disease, cured from a disease. The survival data should have at least two essential variables: the time variable, which is the time from the beginning of the study to the occurrence of the event or to the end of the study, and the second variable is the event variable. The Cox regression can be used when there are several predictors, and some of these predictors are continuous, i.e. continuous variable, or variables such as age and height, and also it can be used for categorical variable or both continuous and categorical predictors, and also it is used mainly for multivariate analysis, so more than one independent variables or predictors, whether they are continuous or they are categorical. The regression will assess simultaneously the effect of several risk factors on the survival time. In another way, the statistical analysis will allow examining factors that influence the hazard ratio or rate for an event, such as death or curance from a disease at a particular time point. And finally, the objective is to build a model to predict specific risk factors. Here in this STATA data view, I had placed 5 different variables. The first one is the time. So the first variable, or the first two variables, the time and the died, are the survival data. So the time is the time at which the individual enters the study until the event occurs or until the end of the study, and it is measured in a scale of years, and it's continuous variable. For the first participant, the duration time was 0.6 years, the second one 2.5, and the third one was 1 year. The second variable is a binary variable, which is an event, which is death. If a person died, is given a value of 1, and if a person is still alive until the end of the study, is given a value of 0. So these two variables are essential variables to perform survival time analysis. The additional 3 different variables, the drug, the sex, and the age, are an independent variable or variables or predictors. Drug is binary. There are 2 drugs here, A and B, and the objective is to examine the effect of drug A or drug B on the survival time of the participant. And the sex again is binary. It has 2 values in it, or 2 levels in it, males or females. And the age is a continuous variable. So we have here 2 categorical or binary variables and 1 continuous variable or predictor. And to investigate whether these predictor can have an influence or an effect on the survival time, then the Cox proportional hazard regression will be used. In the command section here, first declare that the data we have here is a survival data by typing ST and then set space the variable time, then comma, then the event, which is death, and then open a bracket and type the died label and hit enter. So the objective of this study is to investigate the effect of several predictors on the survival time. As shown here from the output, there were 1000 total observation, 14 observation ends or end on or before the entry. We could do some descriptive analysis before we move ahead to do the Cox regression by typing DESC. As shown here, 9 variables are generated. Why? If we type edit and look at the data here, we can see 4 new variables are generated, one for the time and one for D, which is the death status, 0 or 1. We could also look at the first 10 entries in the data here by selecting specific variables or data set by typing list and then space time, then the event died, then underscore D, underscore T for time, and then in 1/10 and hit enter. As shown here, the time is given for the first 10 participants with their status of either live or dead. We could also look at the summary by typing ST sum and hit enter. As shown here, the incidence rate is 0.187 and the survival time median is equal to 4.2. We could also look at the summary by specific predictor. Let's say here by looking at grouping by drug here, and if we type drug and hit enter, a table is generated showing the drug A and drug B and the incident or the incidence rate for each one of them, and the survival time median at 50% for drug A is 5.9 and for drug B is 3.6. So the drug A have influence on increasing the survival time for those who are taking drug A and preventing or prolonging their life survival time compared to drug B. We could do the same for the sex factor by typing ST sum and then space comma space by open a bracket type sex and hit enter to show that there is a difference in the survival mean survival time mean for males and females, and it's higher for males, and the incidence rate is also given here. We could also look at the summary for the age, and as shown here, the age mean is 69.4 for the whole set of data with minimum and maximum. To examine simultaneously the effect of several predictors or risk factors such as the age, the drug, and the sex on the survival time, then Cox proportional hazard regression will be performed. And to do that, in the command section type ST COX, then the first predictor, which is the drug I for categorical, space, then I for sex, and then age, and then hit enter. A table is generated here showing the 3 different predictors, the drug, the sex, and the age. And as shown here, a hazard ratio is produced for each predictor, p-value, and 95% confidence interval for the hazard ratio. For the first predictor, which is the drug, since drug A is taken as a reference and given a value of 1, then drug B will be compared to drug A. After adjusting for the effect of sex and age, taking drug B have an increased 1.91 times hazard ratio compared to those who are taking drug A, and this is significant as the p-value is less than 0.05, or in another way, taking a drug B there is an increase of 91% chance of death from the disease compared to taking drug A. The hazard ratio falls between the upper and the lower values for the 95% confidence interval, and this confirms additional significance of the finding. However, for the gender predictor, which is have two levels in it, males and females, and here females are referred to or compared to males, and after adjusting for the effect of the predictor drug and the predictor age, females have 1.01 times higher hazard ratio compared to males. However, the p-value is greater than 0.05, and this indicates that there is no sufficient evidence to support there is a difference between males and females in terms of hazard ratio of death. So males and females probably have the same hazard ratio for death. Finally, after adjusting for the predictor drug and the predictor sex or gender, there is no sufficient evidence that age is associated with the survival time. The upper and lower value for the 95% confidence has a 1 value in it, or a value of 1. So this is the way to do or perform Cox proportional hazard regression in STATA.